5B Part 2. We have a rocket which has a rest mass of 235,000 kilograms, including 186,000 kilograms of fuel, is sitting at rest in space. When this fuel is burned, it is exhausted from the rocket with a velocity of 38,500 meters per second. We're going to assume that all fuel is emitted at once. What will be the final velocity of the rocket? So first we're going to start with our before. So our before is we have a mass total of 235,000 kilograms. This includes the rocket and the fuel. So it's sitting at rest. Its initial velocity is 0. Now, after we have two different masses. We have the mass of the rocket and the mass of the fuel. The mass of the rocket is 49,000 kilograms and the mass of the fuel is 186,000 kilograms, which is delta M. Now, the final velocity of the fuel is 38,500 meters per second. The question is asking for the final velocity of the rocket. First, we need to determine what type of collision this is. And it is called an inelastic collision because you have two objects or two masses that are together and then they explode and separate. So for inelastic collisions, the kinetic energy is not conserved. So this type of problem is a conservation of momentum problem. Well, what is momentum? Momentum is represented by P, which is a vector, and that equals the mass times the velocity, which is also a vector. Now, momentum is always conserved, so which basically means the initial momentum must equal the final momentum. So the problem that we use is the mass of the rocket plus the mass of the fuel times the initial velocity, and that must equal the mass of the fuel times the velocity, the final velocity of the fuel plus the mass of the rocket times the final velocity of the rocket. Now, what are our zeros for this problem? Well, this side is 0 because the initial velocity is 0. So, what exactly are we trying to figure out? Well, we're trying to figure out the velocity of the rocket. Now, we solve for the velocity of the rocket symbolically, which is the mass of the fuel times the velocity of the fuel divided by the mass of the rocket. Now we just plug in our numbers, which is 860,000 kilograms multiplied by 385, or 38,500 meters per second, divided by 49,000 kilograms. So the final velocity of the rocket is 146,142 meters per second. And that's it.